Hi guys. Whoa, that's loud. It's loud to me. So how's Maker Faire? So, glad to see you young guys. Anyway, my name's Bruce Mackenzie, and you can see the slides on either side. I'm with the Mars Foundation. There's a number of related organizations, Mars Society, National Space Society. I recommend all of them. And what we're especially working on is how to live in space, starting with Mars. Not how to go, not how to travel there, not how to explore. We want to go live there, okay, permanently. And one of the key things is how to build things when you get there, how to use the local materials to do construction. Don't bring everything from Earth. Go to Mars, use the local dirt, etc., and build houses and grow food and live there. And a whole bunch of people have contributed to this presentation. Some of them will be listed as we go along. Our contact info is info@marshome.org. We also are bringing up a new website, marsfoundation.org. Okay, we had a design team of volunteer engineers who put together a design we call the Hillside Settlement. We've got a 100-page report. If anybody wants to do some final editing and help us publish it, let me know. And it goes into a lot of detail on how you do construction on Mars. This particular design was for 12 people to live there. They build a duplicate of that structure every 2 years. So every 2 years, an additional 12 people could arrive. That would be made mostly out of fiberglass, brick, and a little bit of plastic. But even that is a little expensive to send 4 people. By the way, it's very expensive to get to Mars. It's even more expensive to come back from Mars. But it's cheaper than a lot of government programs. It could be afforded by a few private individuals. It's going to happen. The question is when and how and who goes. So anyway, we're trying to cut the cost down rather than sending 12 people. We were working on other designs that might be made only of fiberglass and plastic. And we're trying to get it down even lower price. So here's another proposal that we're currently working on, where you'd send about 10 modules, and then 2 people would land and live there and build it up. And then with help from others, and as soon as possible, additional people would go. I don't have time to go into details, but the numbers you see on the screen are the sequence in which we deploy habitats to live in, workshops, chemical processing, etc. Okay, one of the key things is a fabrication lab. Everybody's seen 3D printers here, right? Okay. By the way, we have an exhibit table indoors in the space area, and we have a non-working 3D printer that you can touch. It's so badly broken you can play with it. And we also have some sample materials that you might make. So come on inside afterwards and see it. But anyway, you could build a spacecraft that could land on Mars. Well, one spacecraft would be the habitat you live in, another would be the greenhouse, the waste processing, etc. But one of them would be a fabrication lab. Have a couple 3D printers, laser cutter, etc. And we're working on using those to build permanent structures on Mars. In this particular plan, after you get maybe the minimum base down on the surface, try to assemble it with robots the best you can. Then 2 people would go to Mars orbit. They'd test it out remotely from Mars orbit, controlling robots that are walking around. And when they're ready, they would descend to Mars. There might be another 3 people in orbit helping them robotically. And the key thing about this is there'd be no ascent craft. That is, there'd be no spacecraft on the surface that could launch you to come back to Earth, because that's about half the cost. That would about double the cost of the mission. Half the cost of a round-trip mission is just the spacecraft and the fuel to get you home. So we want to, with reasonable, minimal risk, get 2 people on the surface building and save the cost of the return trip. This is very risky, but there's, it's a good way to open up a new planet to live on. Okay, so you might have a couple people in orbit controlling the robots. One of them would be the size of a person, so you could remotely from orbit walk around the base, move your hands and look at what the robot is looking at, test out the base, get familiar with it. And maybe, up in the picture, I have an old 3D printer. Maybe you might even try doing a little bit of construction and assembly with these robots. I think things will break. And you won't be able to do it, completely. And as soon as possible, a couple people would land, maybe 4 people, but 2 to 4 people would land, fix all the broken equipment, and then start growing food and manufacturing. A lot of people ask me how you could make materials on Mars. Making brick and fiberglass is the same way you do on Earth. You heat up the rock and sinter it or extrude it and make little fibers. You can also grow plants and get a lot of construction material from plants. Bamboo, wood, cotton, linen. You can get a lot of oils from plants and use those as raw materials. But what you see here is something that will actually make a hydrocarbon, and start the process of making plastics on Mars. This was built by high school students with help from one of the parents. And you can electrolyze water. Oh, there's big ice deposits in a few places on Mars. So Mars does not have trains running by to drown you out. It's very quiet on Mars. The air is so thin you can't really hear too well outdoors. Okay. So Mars has thin air. It's very cold, but because the air is thin, it doesn't chill you too much. The air is mostly carbon dioxide, a little bit of nitrogen you need for fertilizer. And I mentioned ice deposits. And you got dirt, somewhat similar to Earth dirt. Okay, but you can mine the ice and take the water, electrolyze it. So you run electricity through the water and you separate out hydrogen and oxygen. Okay? And this thing, if you can see that cursor moving, there's an input where you put in hydrogen here and Martian air here containing carbon dioxide. And they are combined with a catalyst right here, and it makes methane. Methane is a hydrocarbon. Natural gas is what you know as methane. Also, cows produce methane. And then so it also produces water. This is spontaneous. You don't have to set it on fire. I don't have time for questions until the end, sorry. Okay, and so the methane and water that you produce come in here. Here you chill it and you condense out the water, and then you recycle the water to make more hydrogen. And you're left with methane. Methane can be used for rocket fuel. Steps like this are how you make plastic. Okay, and as I said, this was constructed by high school kids. It doesn't take rocket science. Okay, plastics are a little harder. Frank Krosman put together a fair bit of information on how to make various kinds of plastics. Let me just show that. I won't try to describe it to you, but if you see right here, styrene, ABS is similar to styrene and is one of the things you see in the 3D printers. Ethylene can be used to make polyethylene for milk bottles. Here's polyester resin that we use for gluing together the fiberglass. Okay, getting to 3D printers. So anyway, the big stuff you'd make out of fiberglass, but the small stuff you'd make on 3D printers. I'll get to Lulzbot in a minute, but we're connected with the Lulzbot company that makes 3D printers. And here's a picture of part of their factory. They have about 40 3D printers running continuously, making parts for more 3D printers. And one thing we want to do is send a couple 3D printers to Mars and make more 3D printers, just like they do in this Colorado factory. Okay. By the way, for the medium-sized stuff, if you want to make furniture, kitchen cupboards, tables and chairs, it wouldn't really be cost-effective to use a 3D printer. They're just too slow to make very large objects. So what you might do is extrude sheets of plastic and use a laser cutter to cut out the patterns. So rather than ordering furniture from IKEA, you would order the CAD plans from IKEA or somebody on Earth. They would email you the CAD plans. It would cut out your IKEA shapes, and then you'd assemble your furniture. But the plastics has to be made there. Don't bring it from Earth. For greenhouses, probably the most important thing you can make is growing food, and so you want as many greenhouses. It doesn't rain on Mars, at least not in the past 2 billion years, so you got to irrigate. So you'd want to produce plastics out of the air or out of plant products and make pipes, and then all your fittings and your valves would be made from 3D printers. So these 2 or 4 people on the surface would spend most of their time repairing equipment and growing food. You can also make useful things around the kitchen. I have a little salt shaker that you'd make. I have an impeller that might go in a pump. So picture most of the things for your kitchen would not be brought from Earth. They'd be made after you get there. As soon as possible, these few people would build extra greenhouses, stockpile as much food as possible, bootstrap their manufacturing equipment. And when they have a few years' supply of extra food, initially they'd bring food from Earth, but as soon as possible, they'd start stockpiling food they grow there. Then more people can arrive only bringing themselves, maybe a suitcase of clothing, personal effects. Chances are a lot of the first people to arrive would be scientists. The first 4 would probably be construction engineers, but then you'd have more and more scientists arrive. After you have a small scientific base, then you need everybody. It basically becomes a small town, all walks of life. I should have mentioned this earlier. We have a 3D printer. It's a Lulzbot AO101. It is located in Hawaii at a pretend Mars settlement, a Mars habitat. So there's a program to do dietary and psychological studies at this Mars habitat. If you see the, this green structure, this is what the habitat looks like. It holds 6 people. It really exists. The crew is there for 4 months at a time on this lava field in Hawaii. They're in isolation. And this winter, we are planning to have various tests and demos using the 3D printer to repair things and build things there. And one of the reasons I'm here today is to ask for your help in making suggestions. If you were on Mars, what would you build? If you got a 3D printer on Mars, what would you make? What would be useful?
Doctor.
A doctor. You'd print a 3D doctor. Okay. I have a cartoon of someone who says, no, he's not my boyfriend. I printed him on a 3D printer. Okay, one question, quick.
I was suggesting if you would stockpile parts for everything you have, so there's a breakdown of anything, or a combination breakdown of 3D printers and parts,
okay.
Then you would be able to...
Yeah, so she's saying you'd stockpile parts for everything. Well, you only stockpile extra parts for the critical stuff. So once you get about 3 or 4 3D printers, then you don't really worry about one of them breaking, because you got some spares. But yes, anything that is life critical that you don't have a spare of, you'd start making spares as soon as you arrive. Okay, so anyway, this is the inside of the Mars habitat, and they only go out wearing pretend spacesuits. And so we're looking for ideas of how to use that 3D printer to build something useful. If nobody comes up with ideas, well, tell me afterwards. But we can, we'll start building a greenhouse. Okay. We would like to extend this on to traveling exhibits and museum things. So you could make a pretend Mars habitat out of that trailer and tour the country. We're advising 2 student groups at Worcester Polytechnic Institute in Worcester, Massachusetts. One of them is working on activities to go in a museum. The other's working on the settlement plan itself. And the goal is basically a growing settlement. Okay. And eventually, people will spend the rest of their lives there, hopefully, and end up having families, growing more and more food, building more structures for people to live in, and taking off. I think that's my last slide. Yes. So, and at some point, it would be a small manufacturing city, and then you can start manufacturing pre-assembled modular units that could then be trucked to other places on Mars. So you might have a geology or a mining camp somewhere. You'd have a spaceport somewhere, and you'd have this initial manufacturing. I can take about 5 minutes for 10 minutes for questions. Yes?
How do you get oxygen on Mars?
How do you get oxygen on Mars? Okay, the atmosphere is carbon dioxide. It's too thin to breathe. It's about 1% of the pressure we're breathing now. So 95% carbon dioxide. And after you get a greenhouse up and running, you just slowly pump the outside air into the greenhouse, and the plants will make oxygen for you. And they also make food and building materials like bamboo and linen, paper. Okay. Now, initially, you have to separate the oxygen by some other means. My preferred method is you heat it really hot, either in a solar furnace or with a nuclear reactor. And if you get it hot enough, the CO2 will disassociate. It'll make oxygen and carbon monoxide. And that is dangerous and poisonous. You want to keep it outside. But you can breathe the oxygen. You can use it for rocket fuel. I should say there are materials that are called molecular sieves that can separate it. So you heat it and you separate it. Now you're going to have waste carbon monoxide. I want to mention what you do with that. If you just kind of bubble that through the soil, the carbon monoxide will pull off some iron atoms, and it'll form what's called iron carbonyl. It's a gas. And this gas carries the iron away from the soil. You can pump it into a mold, cool it, and it'll deposit iron inside the mold. So you can actually mold iron objects without ever going through an iron, blast furnace. Any other questions? No, just a minute. She's next. But questions about gas. So that's how you make oxygen. It's about 3% nitrogen and about 2% argon. The nitrogen is good for making fertilizer, or the microbes in the soil will make nitrates. Like soybeans and peanuts have microbes that will make the soil more fertile. And then you can also breathe the oxygen, the nitrogen and argon as mixing gas. Yes?
I know that NASA has different standards of cleanliness for different parts of Mars. It has different standards of cleanliness for different parts of Mars. Wouldn't this steamroll right through their standards when you bring stuff to Mars?
Yeah. Okay, so the question is cleanliness on Mars. I think they have the same standard for everywhere on Mars, but they have different...
The ice caps have a higher standard.
Okay, I think what you're referring to is microbe contamination. We don't want to send microbes to Mars first, then go look for life on Mars and find our own microbes. And yes, it's almost impossible for people to live anywhere without leaving microbes around. So what you would do is first look for microbes with automated sterilized probes. However, the reason we're interested in Mars is as another place to live, to expand civilization. The same reason we expanded out of Africa throughout the world. And sooner or later, there'll be people there. It should be possible to tell the difference between a Martian microbe and an Earth microbe by doing DNA analysis or just chemical analysis. There is also an interesting proposal that if Mars ever had life, it was probably billions of years ago when there were rivers flowing on Mars. And there might have been microbes that evolved. Some of them might have even been blasted off the Earth by an asteroid, come to Earth, evolve into us. So it's possible we have descended from Mars microbes. But it is so cold and so dry on Mars now that if any microbes survive, they had to be kind of as spores or cysts, they're dormant. And they're going to die out sooner or later. They've probably already died out. Their only hope is for us to go find them and give them the same environment they had in the early Mars history so they can revive again. So that is debatable, but that's an interesting proposal. But the answer is yes. As soon as people open an airlock door, there's microbes going to get out, and it's almost impossible to stop that. Yes.
What kind of people are you finding who want to go to Mars and maybe never come back?
Okay, the question is what kind of people would want to go to Mars and maybe never come back? Okay, some of our proposals allow we'll send an ascent craft for the first crew only. And when the first crew figures it's completely safe, then another crew can come. And either the first or second crew can come back on short notice, but not both. Okay, yeah, all right, so we're running the Mars Foundation, and we are working on these technical plans. There was another proposal for a 100-year Starship. There was another proposal for asking for volunteers. This was about 3 years ago. There was a blogger in South Korea who made a mistake and confused all three of those programs. And he said the Mars Foundation is asking for volunteers for a one-way trip in a Korean blog. And we got about 300 applicants in one weekend. And Susan, who was receiving the mail, says, "We're being spammed. Turn it off. Get me off this address." And I said, "No, we're not being spammed. These guys are genuine." But every South Korean who wrote us couldn't write English well. And English is almost a second language in Korea, at least South Korea. So for everyone who wrote us in broken English, there must have been 3 or 4 who went to our website and says, and could read well and says, "Oh no, there's some mistake." So we could have gotten, a few hundred applicants in one weekend.
What do you think is special about it?
Well,
why do they do this?
Okay, just a minute. I'll give you another example and then get to your question. The Mars One organization has asked for volunteers to go to Mars. They have a website out. You can click on it. You can pay an application fee. And what they want to do is select people to go to Mars on a one-way trip, form them into teams, and then run these teams through training and testing as a reality TV show. So if you want to go to Mars and you want to have all your training televised, that's the way to do it. Okay, and they got 200,000 applicants who clicked the apply button, but they refused to say how many actually paid the application fee. Less than 3,000 actually paid the application fee and also publicized their video. So there's enough applicants. As far as who would want to do, oh, by the way, we're working on a much more detailed technical plan than they do, but they're working on how to fund it. So I'm hoping that this will be complementary. Okay, so as far as what kind of people, it's the same reason people have left home throughout history. People from Ireland, when the potatoes, were failing, went to North America to earn a living so more people could come. Some people emigrate for religious reasons, some just for excitement. By the way, I think you would be much safer, even the first crew on Mars would be much safer than explorers were a few hundred years ago. They were going out in really rickety sailing ships, dependent on the weather. They were eating food that was, not well preserved. They were trying to live off the land. A lot of early explorers didn't come back, and I think we are better prepared to settle Mars than almost any time in the past. So for example, you need to have a pressurized habitat. We've been building pressurized airplanes, for 50 years now. But by the way, my father was one of the last people to fly unpressurized airplanes at high altitude in World War II. And then they, as soon as possible, went to pressurized airplanes. And there's just lots of similar examples. Would you like to go down in history comparable to the Jamestown settlers or the Plymouth plantation, or as the people who stayed back in Europe and sent them over? So yeah, there's no shortage of volunteers, but I don't expect the majority of people to want to go. 1 minute, okay. 1 or 2 questions. Yes?
Terraforming, are you planning to incorporate this into your plan?
Okay, terraforming. The short answer is no. Okay, but terraforming means to make a place more like Earth. And there are proposals to go to Mars and change the climate. Spread black soot over the polar ice caps, melt them. There's been a lot of study and disagreement about terraforming. The people that I think have done the most work on it think that we'll never get Mars all the way to be like Earth, where you can walk around, with short sleeve shirts and breathe the air. So you will have to wear protective clothing. But maybe you could get by with just, like what you're wearing, a fall weather coat and breathing from an oxygen mask with a backpack that separates out oxygen from the air. The reason for this is Mars probably has what's called a bistable climate. It can be stable in two conditions. Right now, it's very, very cold and very dry, and the air is very thin. There's a lot of carbon dioxide and water frozen in the soil and in the ice caps. If you melted all that, the air would get thicker, you'd have a greenhouse effect, you'd have global warming, but it probably still wouldn't get you all the way up to what we would like. But you could make it a lot warmer, and once you get it warmer, there'll be enough carbon dioxide in the air that it should stay warm. So it's either cold and dry, or cold, dry, and thin, or somewhat warmer, wetter, and thicker atmosphere. I'm out of time. I can take questions over there, while the next speaker's getting ready, and then I'm going to go into a table indoors. But send us an email at info@marshome.org. So or info@Mars Foundation, either one. I enjoyed it, guys.